Welcome everybody to the Dallas Programming Robotics Group, a Robot Builders Night Virtual for February 4th, 2025. As usual, we will go around the table, and anyone that has anything to present or wants to ask a question, they can spend a few minutes doing so. After that, we'll go to open mic, where we can chit chat, ask questions, stump the club, get help with a project, whatever you need. As a reminder, we record video and audio on these calls. So if you do not want to be seen or heard, turn off your camera and mute your microphone. Aside from that, we have coming up in May, Roborama, with various competitions going on. I'm not sure exactly what we're going to have. Line following, 6-can, mini sumo. I'm not sure all of them yet, quick trip. But we'll get a follow-up on that in the coming weeks anyway. And reminder, there is only 109 days to prepare for this, so get programming. With that, I guess we'll start with our first presenter, which is Ray.
Okay. Let's see if I can get this to actually work. Window.
Yeah, Elm's trying. Okay.
Okay. Can you see that?
Yes.
Yeah. You can? Okay. So you see this screen with a bunch of circles on it here. Okay, so this is the same setup I think that I showed last week. I actually glued one of the long pass filters. Can you see what I'm showing on my camera?
Yeah.
I don't think you can you?
Yeah. Well, we can see it in your video.
Okay. Anyway, one of the long pass filters, I glued it on the back of the lens, and it's on an OpenMV H7. And so the laser's turned on, it's got a line lens on it. And if I pull my hand closer to the robot, where the laser's, catching my hand there at the bottom of the screen, it goes further and further down. That's what's indicating the distance from parallax. And if I go further back, it goes further up. So and there's a serial terminal over here, and that's spitting out the X and Y coordinates of these. They're actually blobs, they're not line segments. And it's not color blobs, it's black and white blobs. And so that's telling me the centroid of the blobs, where the crosshatch is right here. So the X and the Y coordinates. So I actually had a course similar to the one that we've been using, but I didn't put enough paint on it. The reddish colored board was still kind of shining through it, and painted that recently to try to get the reflectivity up, similar to the courses that we've been using for the contest. So anyway, that seems to be working much better. I can, if I'm shining the robot, or shining the laser on one of the goals, it can bring see the different segments of the goal. The center section, it's what's in behind it is much further back, so it shows up higher up in the screen, and the things that it catches further down, just like this, or closer to the laser and the robot, appear further down on the screen. So so this isn't too bad. It's kind of condensing. I'm going to stop it here for a second so we can look at the serial output. So it's giving me 1, 2, 3, 4 different. Let's see, 1, 2, 3, 4. Yeah, 4 different things. This, and it's X and Y. So that's the first one, the 362, and then this is the next one, 3050. Oh, and this is quarter VGA. So that's like 80 by 60 pixels. So 80 this way and 60 this way. And so looks like it's going to be useful for kind of, like I said, like a poor man's LiDAR. And that's just it's one of the examples that I've modified. It actually started out as single color grayscale blob tracking. And that's one of the examples in the OpenMV IDE that you can modify. So I've, instead of quarter VGA, I changed it to quarter VGA. And usually for blob detection, you have auto gain and auto white balance set to false. And it actually works better in this case when set to true. So this, I'm actually, using this in, a room with kind of average lighting that, I would have in it. And it's only seeing the laser. And that's because of that long pass lens that's on the back of the laser, or long pass lens that's on the back of the camera. Or, okay, it's attached to the lens that's on the camera is what I should have said. Anyway, so the that seems to work pretty good. I'm about, let's see, they're about maybe 5 feet back, and it can easily detect, where my hand is or where my fingers are sticking up. So, and I've tested it further back with pieces of the course. Anyway, so that's kind of the progress that I've made with it. There we go. Anyway, so I don't know if anybody's ever going to be interested in that or not, but that's kind of a thing that you can do with pretty much any of the cameras and a pretty cheap laser. You can actually get fairly accurate distance measurements out of it, using parallax. So
well, that's interesting. I find it interesting. I was planning on using an expensive camera, and I'll give this some thought. Thank you.
Sure.
Very impressive applied research, Ray. Thank you.
Oh yeah, it's actually believe it or not, the idea for this came from the Seattle Robotics Club back when they were using, kind of like the cameras that you have in security systems, or at least in my security system. I don't know if that dates it. Probably does. It's old analog cameras, and they did something similar, but they were looking at the analog output to detect, peaks in the waveform, and they actually put it on its side. So it was actually scanning vertically instead of horizontally. And, that was a little easier to get out, to figure out, which pixel was turned on in which column versus which row, because you could have multiple pixels in a row turned on, and it was just a little easier to interpret the information out of the camera. So it's certainly not a new idea. But anyway, so that was all I had.
Well, thanks, Ray. That was very interesting.
Yeah.
Good progress being made on your parallax vision system.
Yeah, it's kind of neat.
Next up, we have Bruce.
Okay, so let me share here. hopefully I'm doing this right. Okay, so 2 weeks ago I was talking about getting a simple compass working on the Raspberry Pi 5, and using Aider and LLMs, and something I mentioned, I think I caught Paul's attention, was I'm getting to it. Is that I used this for the PIP3 install brake systems packages, and I didn't like it, and so I switched to using a virtual environment, and after difficulties with that, I used lots of AI, and I finally ended up using Perplexity, and I gave it the problem that I was encountering, and Perplexity responded with using Python packages within a ROS2 Jazzy node is a known problem. Not being able to use them, it's a known problem, and they're working on it. So I went back to brake system packages, and I, based on my other updates I've done, I got everything working. So I'm really pleased with that. The planet's aligned, very pleased. A couple of key things is the brake system packages, and then also most people will come across this one. The setting the privileges on that device. So it's pretty straightforward, but key things is that brake system packages. And there's also Docker images that do not work. So Jazzy Perception, I'm sure works. Here I'm using Jazzy Perception Mobile. This may be out of date. Okay, these environment variables. This is definitely out of date. I need to eliminate that. And then I want to show you my specification file, which I showed 2 weeks ago. So this is now 2 weeks ago, I ran this piecemeal. So about 2 hours before this meeting, I ran this, and I ran it all in one shot. So I selected everything, copied it, and threw it at the Aider prompt. And so here in Aider, I'm using the O1 model for reasoning, and Cloud 3.5 Sonnet for file editing. And this works out really good. And like I said, 2 weeks ago, I learned this from Indie Dev Dan. Some of these things I already knew, but I just told it what I wanted. I've updated this from 2 weeks ago. I now 2 weeks ago I was actually including the Compass code in here, and now I just tell it to read it directly from the file. So you can see here that it has access to read the file. And then this is just straight from publisher code, straight from the ROS2 website. And then I just tell it step by step what to do. And so I have 3 steps here. And it worked the first time. I mean, it covered all 3 steps in a single pass and got them correct. And so one little cool trick that I've added is to keep my README up to date. So I tell it to update the README.md file to reflect this change at the top of the list in the update section. And so I gave it 3 tasks, and it commented all of it for me. It's just that simple. It's just so incredibly awesome, in my opinion. Now, one of the other things that I want to point out that I did is that I told it to write this section, testing the node. And so let's see where I specified that. Right here. All I did was enter that. Update readme.md with a testing node section. That's all I told it to do. And it wrote all of that. And like I said, the spec file, I copied and pasted all of it. It did all of this in a single pass, which took, I don't know, 3 or 4 minutes. So I'm very pleased. Very pleased. So that's it for me.
Does is the code a little bloated? Does it seem like there's a lot of stuff in there that doesn't need to be, or is it just, do you think it's pretty efficient?
Well, it depends on what you believe in, what is actually needed. So I had it put in a bunch of things that a lot of people would not. So see, all of this, well, I started with Compass.py. Let's see if I can find that. That's in this directory. There it is. So this is what I started with. Okay, it's quite minimalistic. And then from there, it produced this class. So I'm really big on documentation. So I explicitly told it to write doc strings. I explicitly told it to write this line. Well, I told it to write the install requirement. It did make one mistake. It missed the rpi.gpio package. That's the one mistake that it made. But I already do that through other testing. And, you know, if you call this bloated code, so be it. But I specifically told it to make sure that the code ran even if there were problems. So let's go back to, yeah, Ray. Was that right? So let's see, right here. The software is designed to run on boards such as the Raspberry Pi. However, during development, it does not have access to GPI ports for some methods. So some methods in this file will fail. Update the code to print error messages and default values. So that the code does not stop on a development machine. So I told it to put in things, but you're talking to an LLM, in this case O1, and you just tell it in general what you want. and it's quite good.
Hmm.
And with the exception of that one package error, it got this on one pass.
Wow.
I'm done. Oh, let me stop sharing.
Yeah, I find it interesting, the AI.
So do I.
And I would
Even-
have to defend it missing the GPIO Pi package, because hadn't that been depreciated? I mean,
That's a good question.
officially, I think it's been depreciated, so that may explain why the AI didn't recommend using it or neglected to include it.
You know what? During my work on this, somewhere along the line, I do believe an LLM told me that, and I left that in there. And the key thing was the other two packages. So once it understood to use the what two other packages to use, then you're right. The GPIO package is no longer needed. And see, I actually forced this issue. So that's something else that I need to remove.
What user interface did you use for this?
It doesn't matter. It
No,
actually
I know it does. Well, I'm just curious whether you used the
does code.
the VS Code with the Copilot plugin.
Oh no, I'm sorry if I didn't point it out. I'm using Aider.
Ada.
Yeah.
AIDER.
Yeah,
Yeah.
okay. I've heard about it. And is that kind of tied into Visual Studio Code, or I've seen YouTube videos where it's like a command line driven thing? How did you use that?
It's command line. So I should probably share my screen again.
And you said behind the scenes Ada was using O1.
Yes, that's part of what I want to show you. Okay, so you can see my screen. I don't like typing in commands. I don't. And so this script file here was written for me using an AI. And so by default, the default is to use the O1 model. And by default, they use O1, specifically the O1 preview model. I tell Aider to go into architect mode, which I think O1 preview automatically does. And then I'm using the Claude 3.5 Sonnet, the October 22nd version for the editor. And then I've used this also. I've used the R1 model a lot. And so in this, okay, so Aider also works with, you should be using Git, okay? So I have a strong opinion about that. And Aider works with Git. And something nice that it does is that every time it makes a change, it does a commit. And so like here, I added a command line argument for handling model selection and script. So that's my aider underscore run .sh script. And so you could roll these back, which I've only done a couple of times. So I've only done this less than 1% of the time to actually roll it back, which is the /undo command. And I'll just tell you that some of the key commands are /add, so you can add a file name. Oh, so it's, and another command is drop. So I'm going to tell it to drop all. And I'm at the bottom of my screen. So it automatically fills in things. So add the Docker file, add the README file. So I have two READMEs, tab, enter. So let's see, it's drop, add. This clears your conversation history, /clear. And then I can't remember what the command is to clear the screen. Control-Shift-T or something like that. Control-Dot, Control-Period, something like that. I used to use it, I quit using it. But there's a tremendous amount to get to this point. But now that I'm here, I want to make this repo public. And I want to make it so that people can drop in code that requires Python packages. And then you just use aider with its specification file to generate the publisher. I want to make it very simple. And I think this is also going to apply to NVIDIA Jetson Orin Nano Super, because it too is, well, some of these things that I ran into were specific to the Pi, which is a ARM64 architecture, and so is the NVIDIA board. But I believe that given what I have now, I can drop in new code for a sensor, then update my specs file, and go through the process and get an operational publisher. You do have to pop over to the Pi, and you have to do a colcon build. But actually, all of that stuff is in my notes. It's actually in the spec file. See right here, it says CD into the source directory. Run that. We'll move up a level, colcon build. Because I'm telling the LLM that these commands have already been executed inside of the container. And something else I do is I build all these script files. Like I said, I don't like memorizing command lines. So build does a Docker build. And then optionally I can put in no cache. And then I have a run. So I just type in /run.sh. This is a little bit of a joke. Pataina, that's Filipino for kill now. So what this does, it kills a bunch of directories from the colcon build. You have the build install log directories, plus in this case, I'm doing the publishing. And then so I've shown this file, but the place the other key command is exit. So the star dater, that's what I do. /dater_run.sh. And it kicks it off. So by default, it's 01 model, 535 Sonnet. I need to get familiar why it uses the weak model. And here's a key thing. It's used to using Git repos. So Aider was one of the first pure programming frameworks that could do the multi-file editing. And so let's go back to the spec. So I told it to add all of these files, and so it knew about them. Now watch what happens when let's see if it already has this open. Setup.py. So I didn't even have to tell it. It went into setup.py and it did this entry point. I mean, how awesome is that? I didn't even tell it to do it. But I knew that if I didn't specify that file here, I knew that it would, based on previous experience, I knew that it would find it and ask me to add it to the session. And so I specifically called it out. And like I said, it only took like 3 minutes thinking to process all of that and do all the work. And then I pushed that to GitHub and went to my Pi. I have a Pi 5, did a Git pull and did my, it would be a .build, a .run, and it even gave me instructions on, let's see if they're still up here, instructions on how I would test to see if it worked. Oh, I guess it ultimately put that in the testing mode, which would end up if I read. So it gave me, I remember I did tell it to create this, but I gave it no specifications on what to do. And it came up with all of these instructions. And it worked. Can't beat it with a stick.
So does Aider use DeepSeek, or is it part of DeepSeek, or?
Oh no, it's a separate framework, and you can connect to whatever model you want. So let's go to Aider run. I would have to pull up the web page, but there's a whole list of models you can run. You can run the 01. You can now use the what's the latest and greatest 03 Mini. I mean, they've already updated it, so that you can run the 03 Mini and R1, and there's probably over 20 different models to run with that. And so the latest models are reasoning models. O1, O3, R1. Those are all reasoning models. So I use those for the heavy lifting. And I mean, instead of using O1 preview, I could have used Claude 3.5 Sonnet. There's tremendous amount of flexibility to it. It's vendor independent. And you can run stuff locally if you want to. R1 is easy to run locally. There's a gazillion things on Hugging Face that you can run locally. I have a larger GPU, but there's a lot of people out there doing videos on running models such as the O1 Mini on the new NVIDIA card, Jetson Orin Nano Super. By the way, I bought one. So that's my next step. Oh, that's my next step is plug that in and make sure my Compass works with it.
We didn't get a good view of what that was, Bruce. It just showed up as a gray, like a gray mat.
It's the Jetson Orin Nano Developer Kit. It's the one for I've heard a gazillion things about. It's $249. Okay, so it was out of stock at arrow.com, as in bow and arrow, arrow.com. It was out of stock, and I paid a premium to get it through Walmart.
I was going to say, prices should have gone down on that,
didn't
didn't it? Didn't the stock take a huge nosedive? I don't. Maybe it's back up, but
I believe it came right back up.
yeah.
So there's one YouTuber said that, you know, the drop. Well, the drop didn't happen until 5 days after the announcement of Model Y. So he made a case for that's not why the NVIDIA stock dropped. It wasn't for about R1. And then it came back up. I don't know how far. But I still believe strongly in the AI stocks. Anything else?
Well, thank you very much, Bruce. It's an interesting take on programming with ROS and Pi together.
Ross and what?
Next up, Tom. I'm deferring you for to let Elm go first. She's on a time limited basis. So Elm, if you would like to ask a question or present whatever you're going to do.
We'll present our robot. David is also with us. So this is our robot. We have it preloaded with a specimen. Right now we have an Auton that can do one specimen. If you want to run it, Anda.
Yeah, that's Anda. David's online.
All right, ready?
Mm-hmm.
All right.
That's our Auton right now. We plan to have it do 2 to 3 more. We just put some distance sensors on it, so it's sensing the distance from this bar down here right now, and using that to get this one accurate. We're adding them to the sides right now and figuring out the code for that. But besides that, do you want to run driver controls?
Yeah.
This is our outtake, and this is our intake. Here's the intake. So our intake has a color sensor in here. So for yellow, the neutral color, and whatever color lines we're on, it'll keep those blocks. But for the other ones, it'll spit it out. It's relatively quick and it's on a preset. It
You want to
can
demo that?
sorting through blocks.
Yeah, just going to pick up a block.
Yeah, here. Just like shove it over there. So like spat out some of the blue ones. It's like really quick with it and it automatically brings it back over here. And then it has a kind of like eject function. So like the human player can add a clip to it. And then actually I'm gonna put this here. We have presets in place so that the outtake can come and grab it off the wall.
Yeah, nice.
Presets here for hooking it on quicker. Most of our stuff is on presets right now, but the only thing we're working on right now is our improved Auton and then the transfer between the intake and the outtake for the yellow blocks. But I think that's our robot.
That's very nice. Thank you. What processor are you using?
We're using Android Studio.
Oh, as far as processor, so FTC, like on the robot.
Yeah.
So all FTC robots have to use a Rev control hub, which is it's basically an Android phone in there, has Wi-Fi, connects to another device that we plug our controllers into, connects to all the motors, has a battery. And I think it's basically just a dumbed down, it's a Snapdragon, Qualcomm something.
Okay. Thank you.
Yeah.
That's cool.
But it also has built-in motor controllers.
I'll talk for you.
Okay.
It has built-in motor controllers and digital I/O ports, I2C buses, 4 of them, and analog I/O. Oh, and 6 servos.
And I see y'all have the requisite number of zip ties on it as well.
It's got plenty of those.
And cardboard too.
That's for safety. The robot, I think we fixed it now. We had this mounted the wrong way, so it would slip into the middle, but it should be fixed now. Actually, it's not too bad. It was worse.
It definitely does.
It was worse before, but this is there as a safety precaution, which we plan to fix better with some 3D printing.
We've got a nice mix of carbon fiber and cardboard.
Yeah, that would do an awesome job harvesting my chicken eggs.
Well, that's excellent. I believe that's a gold star for you guys because you had the robot moving and you had it in autonomous, I believe, mode to to place a brick on the bar. I don't know what you called the brick, the red brick with the
It's the specimen.
the specimen. So you did that at least once, I believe, in autonomous mode.
Yes, most of the values are preset too. So once we can get the driving pathway down, we should be able to replicate.
Great progress. Looking good.
Yeah, so I'm looking at it, and it's a different design than the Iron Rain one. So
The Iron Rain one's over there.
Yeah, we're 2 separate teams, but we use a lot of the same materials. And
What's your team name?
Iron Giant. Gotta have
Iron
the iron in
Giant?
it. Yep.
Okay, I'm just re-putting this.
So I guess that implies it's bigger than Iron Rain. maybe?
Oh, 100%.
Yeah. So
Iron
when is the
Range Big
competition?
Brother?
Our next
We have a meet
competition,
Saturday.
yes, is this Saturday.
Oh wow.
Lots of progress to be made.
Ah,
Good luck with
3D
the
printing.
competition.
Thank you.
Yeah.
Yeah, there's some steep competition there, some good teams, so we'll see how it goes.
Yeah.
It'll be fun.
I wish I could design it.
Mhm.
That's great.
Yeah, there's a bunch of CAD and communication with our mentor and our sister teams and a whole bunch of stuff that went into this robot. So it's a real fun process.
Code in Python in particular, or C, or
Java.
Java. Okay.
That's
It's
weird.
not the first language you think of for robotics, but it does tie with the high school curriculum.
It works.
Do you want to talk about PID?
Oh, okay. So we got the PID controller working. That's why we got these distance sensors mounted. So we're playing around with that right now. We have it implemented for Auton, and if we can figure it out better, maybe we can use it during some of the driver parts of the challenge. But right now it's mounted to be eye level with the bar, so it still can read accurately, but I don't know, it made the Auton be programmed in probably 5 minutes.
Dang. So we're basically, I wasn't there when we got this all set up, but we have about 3 distance sensors on our robot, one on either side. That's the little green light. And then there's one on the bottom right there. That's also the green light. And they're little rev distance sensors, accurate to about 2 meters, 2 inches to 2 meters. And that's something they got implemented today, but we use them at different stages throughout our autonomous and hopefully driver controlled in the future to try and make it a little more accurate than just odometry.
David, I'd like the use of the 2 systems, the Imperial and the SI, 2 inches
Oh,
to
yeah.
2 meters.
Gotta have really comparable there.
So what do the 2 side sensors do? What are they measuring?
So these are going to be used for our Auton. So the field will have these April tags that you're supposed to read with a camera, but we figure that we can use the distance sensor to just tell us how far away our robot is, because the field's going to have 3 blocks preset right here. So that's what we're trying to implement right now. We'll use the distance sensor on the side to accurately line up the robot this way so that it can aim for these blocks.
Does the distance sensor work well with the clear plexiglass?
We were told no.
Okay. I was curious.
That's why we're aiming for the paper.
Oh,
Right.
the paper.
Paper
I
that's
gotcha.
always in that location behind the plastic. Yeah. So what is the PID loop giving you? What's it doing better than just a proportional?
To be honest, this is my first time coding, so before I would just kind of either run it on timers or run it on the odometry ticks, and I just keep running it back and forth, testing it to see if it worked inch by inch. So
Like some of the problems that
efficient
come out of
way.
that is like if the odometry pods slip at all while we're running it, or another robot hits it, or like different fields will have different amounts of like contact with our odometry pods. This helps account for that.
Plus, we had to have a very strict kind of routine for setting our robot up. We'd have to make sure it was like the exact distance away from the wall and kind of, yeah.
Oh, and Elm, are we still planning on using the camera?
We
For
can, but
detection?
also the distance sensors seem to do just fine. The only thing I'd use the camera for is to align us with the blocks, but we have a Logitech camera in here. The code should the code can make based off of the color blob on the screen tell how far away a block is away. It's right here. It uses the focal length and some calculations with that versus the distance the object is away in real life, and then how much it is, just like the measurements of it. It does some calculations and then, yeah, it compares that to pixel width, but we might mount it on the front or back of our robot to better align it with the blocks over here.
So you said that you're not going to be reading the April tags.
Nope.
Okay.
We might. It's just we have like a few days to do this.
Oh, yeah.
Yeah, we could advise them on the how smart it is to make code changes the day before a competition.
Not very smart.
I've tried it before. Not smart.
Last time, technically, it wasn't the day before, it was the morning of the competition.
Or between matches.
Yep.
It survived.
Yeah. But if it's failing, then you have no choice. You gotta try something. Yeah.
Well, it just didn't have code, so
yeah,
we got it built the night before, and we coded it the morning of. So
right. Wow. I'm amazed. It's great.
I like to say partially coded.
It got as much coding as it could get in like 5 hours.
That is tough.
So I'll brag for just a sec and just say that we've got 3 teams that worked out of here, and all 3 competed last Saturday, and they all advanced.
Good.
So
good.
And 2 of them are competing again this Saturday.
Well, congratulations.
Iron Giant. So yeah, they got a lot of work to do.
Yes.
Great job, guys.
Yes. But for information, Elm was one of the actors in our play that we had for the last month.
Cool.
She was a young lady, Ari.
Multi-talented.
Mm-hmm. All right.
Was that
I
it,
think we're
guys?
done. Yeah, I think that's it. Thank you.
Thank you guys very much for presenting to us. We're always look forward to seeing your results and your work ongoing. So keep it up. Good luck on the weekend, and hopefully you advance again.
Thank you.
Thank you.
Next up, we have Tom.
Okay. I presented or was part of a smart camera panel at the Dallas AGM the weekend, I guess about 10 days ago. And in that presentation, we talked about several different smart camera applications, including one I had built based on an ESP32. I was reasonably happy with what I built in terms of the use case I had, but wanted to look at what my next steps would be in terms of producing a better object recognizer that was camera based. So I did a market survey, which I also presented in that panel 2 weeks ago. And that caused me to be interested in the next step in terms of what I discovered in my market research. I'm going to share that research quickly. Oh, cannot share. Hang on a sec. Try that again.
Yeah, I got that error a couple times. I don't know what causes that.
How about now? Okay,
Yeah.
I'm sharing now.
Yeah.
So this is you can see my mouse moving on the screen, I assume?
Yeah.
So this is the first page of the spreadsheet of that market summary. At the top, the cheapest unit was the ESP32 cam-based cone detector that I built when I realized I would need one in order to effectively compete in an outdoor contest. It worked, just barely. So I'm pretty happy with it. And it was certainly cheap enough and used stuff I had lying around. The next entry on my list, when I sorted them based on a rough estimate of cost and capability, was going to be the Seed Grove Vision AI version 2. Something new for me, it contains a neural processing unit along with some 32-bit microprocessors. So I was interested in understanding better what these things were actually capable of. So I had done some research to produce some more detailed analyses of what a Seed Grove would look like compared to similar units in the same price performance range. We didn't have time to present that material at the AGM meeting 2 weeks ago, so I thought I'd cover it here. There's 3 pages here that describe the 3 different things I found that seemed relevant. The first is an article from Hackster.io a year ago entitled Computer Vision at the Edge with Grove Vision AI Module version 2, which is the one that was on my spreadsheet. This particular author produced a simple machine learning model, which was a 2-object classifier. He's basically trained this thing to identify the blue robot or the green object. Very, very simple case. Then he ran it on 5 different pieces of hardware. The hardware on the left is exactly the one that I had, the ESP32 cam. And his frame rate, his ability to execute this thing over time, is about the same as my experience. He's doing 1.5 frames per second. And my machine learning inference engine, which was only looking for orange cones, could do about 2 frames per second. The next unit is very similar, but it uses the ESP32S3 instead of the basic ESP32, which he was able to run at 7 frames per second on the same model. Now that's impressive. I had no idea that the S3s were that much more capable than the regular ESP32s. So that was kind of nice news, but it compares those 2 very neatly. The next 2 hardware cases that he ran on are both from the Arduino Foundation. There's a Nikola Vision, which you may have heard of, relatively expensive unit, which basically provides a tremendous amount of capability, all within an extremely tiny printed circuit board. Runs at about 12 frames per second. So it's not terribly outstanding, but it's not bad. The Nikola Vision device, of course, is very expensive relative to being a low-end microcomputer. The next one is the Potentia H7, also from Arduino, ran at the same speed. Neither of these units, none of these first 4 cases contain any form of specialized neural processing unit. The case on the right, the example on the right, is the Nikola Vision AI unit. He ran that at 167 frames per second, running the exact same machine learning inference engine. So that's an extremely impressive gain for a device which I believe the US price for this thing is about $16. So that's pretty cheap. That's not a whole lot more than an ESP32. So that was my first test case that gave me a little more detailed feeling for how well the Grove Vision AI unit would compare with the ESP CAM unit that I had built. It really, really, really tremendous increase. The next case I looked at was a paper presented at the ARM Developers Summit in 2021. This particular presenter is a developer at a small development company that produces technology that's intended to be able to understand spoken words with extremely high reliability. They had been doing a lot of work with embedded microcomputers, his one of his baseline cases was a Core M7 running at 500 megahertz. No neural processing units on board. The model that he's running is a model that is intended to differentiate between 12 different spoken words with a very high degree of accuracy. So that was the model he's running. Base case, the Cortex M7 at 500 meg. His two improvement cases were running the Ethos U55 neural processing unit, two different models. And that's of interest to me because that's the unit that's inside the Grove Vision AI. It has the Ethos U55 in it. His test cases were for a 35 Mac unit and a 256 Mac unit. Mac units are basically multiply accumulate cores, and these are cores in parallel. So 32 parallel processors here, 256 parallel processors here. The Grove Vision AI version 2 unit uses a U5564. So it has 64 parallel processing units on board. So this presenter was seeing improvements from about 3.5 inference loops per second to somewhere between 100 and 150, depending how many parallel Macs there are. The Grove Vision AI unit would sit kind of in the middle here. It has 64 Macs, although it only runs at 400 megahertz. So, you know, would it have run this test case at 110, 120 inferences per second? It would run it pretty fast. Another example that demonstrates in a practical sense that this Grove Vision AI unit would probably really do well. The third example I found is another article from Hackster.io written in early 2024, which compared a number of different low-end artificial intelligence vision boards. Sort of exactly the kind of thing that I was interested in looking at. The top two cases are version 1 and version 2 of the Grove Vision AI system. The Grove Vision AI version 2 is the one that I was interested in. He's able to run on his particular model test case, I forget what it is, he was able to run it at 30 inferences per second, 30 frames per second. The version 1 would only run at 3. Not a good idea to buy the version 1 if you find any, although they haven't been manufactured for a few years. They did not contain a neural processing unit. They only contained a digital signal processor. So they aren't nearly as powerful. The next two on his list are both ESP32s, an ESP32i, which he was able to get running at about 6 frames per second. Similarly, the ESP32 S3 Sense. I believe those are essentially the same device manufactured by two different companies. The first one is Espressiv's version, and this one is a Seed version. I believe Seed produces the Zao series, Seed Studios. Finally, the fifth one in his list is the Arduino NicolaVision again, running at about 6 frames per second. As a baseline, he threw in a Raspberry Pi 4B without any neural processing capability, but with just raw processing power. And it ran that model at about 115 frames per second. Similar to the case that I ran into when I took the machine learning model that I had produced to run on my ESP32 CAM, which could run at about 2 frames per second. And then I simulated it using the Edge Impulse simulation tools, and I ran my model on a Raspberry Pi 4B in simulation, and it ran about 300 frames per second in simulation. So if you have a Raspberry Pi 4B kicking around, it's not a bad machine learning inference engine execution tool. But most people don't have one lying around to use for this purpose. And they're pretty large and a little power hungry. Anyway, those were the three real world examples I came up with a fair amount of comparative detail in sort of real world applications of these things. I went out and bought a Grove Vision AI version 2, and so far I'm quite happy with my initial results with using it, which I'll show you in a minute. But I wanted to show you something else while I have this file open. I showed some of the smart panel discussion material at the Vancouver robotics meeting, which I was at on the weekend. So I showed them my ESP32 stuff, talked about the market summary. and went through some of this stuff. But while I was preparing for this past weekend, I ran across another OpenRobot article, which I had not learned about before. This is a project called OpenBot. The project came out of the Intel Intelligent Machines Research Lab. That's where these two guys were working at the time. This is from about 4 or 5 years ago. Dr. Colton was running Intel's Intelligent Machines Research Lab, and this gentleman, Dr. Mueller, was working for him at the time. They also are avid hobbyists in robotics and model aircraft, which tends to drive the fact that although they're performing very sophisticated research for Intel, they're also doing some pretty fun stuff on the side. What these guys said was, if you wanted to do research and you wanted some real robots to use in your robotic research work, real laboratory robots are really, really expensive. So they figured out a way to take a standard smartphone, an older smartphone, stick it on a cheap chassis, and use it as a robot with an extremely significant amount of intelligence and sensor capability, including cameras, which can be programmed with machine learning algorithms. This paper is quite extensive and does a really good job of explaining how they went about doing that and testing what they produced. They tested about 10 different old smartphones. They built 7 different chassis of different types to mount them on, and extensively tested them with 2 different artificial intelligence machine learning object recognizers. Very, very interesting research, well worth reading and very easy to read. A little bit more of what they did. The robots they produced typically have either an Arduino or an ESP32 on board. Many of you will recognize this typical shape. These guys happen to like 4-wheel drive or 4-wheel robots. They stick some simple sensors on them. There's an ultrasonic sensor at the front, a little bit of odometry on the wheels, a battery pack, an Arduino, and a serial interface to the phone. So you plug the USB port of your phone into the USB port on the Arduino, and that's all the communications you need. They have provided all the code that runs as an application on board the Android phone, and have provided a number of examples of things you can do with them and the development environment that's available to extend that. I threw in a little bit of a table here that's unfortunately hard to read that showed some of their formal test results of how well these environments work.
Or how old the phones were that they used.
I say that again, Ray?
Or how old the phones were that they used. There's like
and they deliberately picked old phones because they said the whole point here is to make it cheap, and I like cheap. I was mentioning to a few of you earlier that my cell phone provider told me I can't use my 11-year-old Android phone anymore because it won't be supported in a few months. So I had to buy this great big monster. So I have an Android phone that's just sitting here on my workbench ready to use.
There you go.
Hey, Tom, I still use one of those phones on the list.
I got it
right. Wow.
Pixel 4 XL.
Yeah, me too.
Well, you guys are all set too.
Yeah. So what are they
buy
up
a
to
new
now?
phone,
Pixel 8 or something?
I'm not giving up my phone.
So well, I'm going to be forced to give up mine because they said by June they would be switching all of their voice services to 4G LTE, and my phone doesn't support voice on 4G LTE, so I had to get a new one. Anyway, they also created a website. The website doesn't have a lot on it other than a whole lot of video examples that they took during their testing phases. And those are worth watching to see what they've actually got going on. This example robot chassis happens to be one of the higher end of their units. It's 4-wheel drive. It's got an ESP32 on it instead of an Android. But all of the examples that they gave are cheap. And most importantly, there's also a GitHub. Let me back up one page here, maybe. Let me find out where. Yeah, right down here in the corner. It's this damn thing out of the way here. Down here in the corner, I provided links to the paper, the link to their website, which is easy. And then from their website, you can also get to their GitHub. The GitHub is really the place to go. The GitHub is a wealth of information, including the paper. The several papers on this topic are on the GitHub. But on the GitHub, there's all of the design plans for all of the robotic bodies they built and tested. There's all of the firmware to run on the robotic bodies. And there's all of the firmware and all the links to the development tools for whatever it is you want to put on board the Android phone. The GitHub is a fabulous repository of material that supports this project. It's well worth looking at. I had also stuck in a little bit of material on these two authors because I couldn't believe that somebody who said that they worked at the Intel Intelligent Machines Laboratory would bother with this particular project, because it kind of seemed to be beneath Intel. But that's when I discovered, first of all, that these are a couple of pretty high-powered guys. Every time I move my mouse around, I incur this stupid box. Dr. Coulton is currently a chief scientist at Apple and is the director of their international research organization. Prior to that, he was chief scientist at Intel and developed their Global Intelligent Systems Research Laboratory. These are pretty high-powered folks. Coulton has degrees, PhDs in computer science. Mueller has PhDs in electrical engineering. And wherever Coulton went, Mueller followed. So they've all been the same places. And that's where I also learned, when I looked at their CVs, I learned that they have published extensively in both robotics and autonomous drone hobby magazines. So that's clearly their other interest in life. So pretty impressive guys. Very, very interesting articles. Let me get rid of that. And other people like what they're doing as well. This is from the Donkey Car website, where this particular author has written a few articles that said, OpenBot is a fabulous thing. I don't like four-wheel robots. Here's a two-wheel robot design and a bunch of other improvements. So the Donkey Car website is also an interesting place to go and have a look at this stuff. Very, very inexpensive approach to relatively sophisticated autonomous robots with vision mechanisms on board them, for what it's worth. And I'm just going to switch to one more page that might be interesting, and that is back to this window. Let's see how lucky I am. Can I find it? Not yet. Let's put it up. I discovered you can't show a window if you don't have the window showing. Yeah, this one. Okay. So I bought a Grove Vision AI unit version 2, and I made use of the Seed Studios AI machine learning training platform, which they call SenseCraft AI, which supports all of the machine learning oriented products that Seed Studio sells. And I used one of their existing pre-created models that runs on the Vision AI unit, which happens to look for traffic cones. It happens to identify traffic cones. So I downloaded that model from their examples. They have 400 or 500 different examples up there. Downloaded it onto the Vision and stuck it up here in my workshop and pointed it at my test cone, which is what I was using to test my ESP32 device that I built. And lo and behold, the doggone thing works really, really well. I'm quite impressed. I started to work at implementing my own machine learning model using my own cone images, actually Bob Cook's cone images. That situation is a lot more difficult to do than I thought it would be. I'll be looking for some more assistance. I know, Pat, you're a little farther down that road than I am. It's not as simple as I thought it would be. So I have some more learning to do in how to use my own images to produce a model to run on Vision AI. We'll see how it goes. Anyway, I was very impressed with, I've only had it a few days. I'm very impressed with the way it's looking so far. And I will test it on cans for the 6 can contest. As you can see, there's a can ready to have pictures taken over there. That's it. Any questions?
Well, it seems like it did pretty good right there. It found the cone, but didn't call the can a cone.
Isn't that amazing?
Yeah.
Now, I'm using the Vision with a Raspberry Pi version 1 camera, which is one of the recommended cameras to use with it. The camera, I find, has a couple of problems in this application. One of them is the camera has a relatively narrow field of view. It's even narrower than the camera that I used on my ESP32 cam. This has only got about a 52 or 53 degree horizontal field of view, which is not very wide. The other problem is that it's fixed focus, very, very simple, cheap lens. And it's a fixed focus, focused out at infinity, which means that I can pick up these cameras, or I can pick up these cones 20 feet away. But if the cone gets within 2.5 feet of the camera, it won't pick it up anymore. Because it's out of focus, I guess. I don't know. So I have some more work to do to understand that problem and see if I can deal with, I think, the optical problem. But we'll see.
That far away, is it just looking at, 100% orange in the, a section of the cone?
And I was wondering if that's what it was. I had the same problem with the ESP32 cam unit, but its range, it ran down to 1 foot. So inside of 1 foot, it couldn't recognize a cam or a cone. But this one's at 2.5 feet. So
yeah,
we'll see. Anyway, the initial testing was great. I'm really
well, I was looking at the OpenBot website, and they have a really cool multi-terrain vehicle.
Yeah.
Design.
The one with the 6 wheels. Yeah, and I think the plans to make that are in the GitHub as well.
Tom, I'd like to make a comment about that problem with getting the cone too close. So my question becomes, did you train on images that were snapshots of the cone being really close?
For my ESP32 cam project, yes. For this one, I didn't produce any of these images. This is a stock model out of the SenseCraft AI website.
Okay.
It's a huge model, but the cones are of all different kinds. So I was very surprised it picked up my cone. Any other questions?
That's great, Tom.
Let's shut this down. I know that
I've got a suggestion for your cone search when you were close to the cones. And that would be to, I don't know if it's capable on that camera, but switch to blob detection.
And I understand your suggestion, and it's a good one. What it would take to do it, I have no idea.
Any other questions for Tom?
Yeah, I just had a comment. I know on the mix cam that you definitely can't call these fisheye lenses on them. They're fairly narrow field of view as well. So yeah, that's kind of always a trade-off. You want to see enough of the surrounding, but not so much of it that it shrinks what you're actually looking for down to nothing, or something that's too small to detect. So
the various Raspberry Pi forums have a few suggestions on how to solve the problem with the original version 1 Raspberry Pi cam, but none of the suggestions are very practical. The lens will come off, but it's a 6mm non-standard mount, and there isn't a hell of a lot you can do with it. So
yeah, it's like I kind of bought an assortment of different lenses. Like that one's, you can tell it's almost like a fisheye lens. It's I think close to 180 degrees, but you get lots of distortion. Straight lines look like they're curved, and
yeah,
it tends to shrink things down pretty small because you're seeing so much of
it's it's been suggested that I should adjust the lens. That's why the lens is threaded, so you can change its focal point. It's been suggested that one should try to modify that just a teensy bit, so it's not focused quite so far out at infinity. The problem is that they glue the lens together after they adjust it. So the first problem is to get the glue off of it.
Without breaking it, yeah.
And then re-glue it again after you get it adjusted. So,
yeah.
We'll see. Nonetheless, I am really, really happy with this Grove Vision AI unit. Their platform for doing training is not nearly as nice to use when you're going to try to train something as the Edge Impulse platform I've been using. But when I took a look at the process of taking a model created on Edge Impulse and then transferring it and uploading the model itself into the SenseCraft AI platform, so that the Sense AI platform could do the specialized compilations to create the blob that has to go on the Ethos U55 chip, the mechanism that's documented doesn't work. I was going to ask the Seed Studio wiki about this, because they have a very, very good wiki, but their wiki got attacked and shut down 10 days ago, and it's not their communications, their email's not working yet. So you can't ask them any questions right now. They got hacked.
Yeah,
we'll see.
Well, I was intrigued about the OpenBot that you showed.
Yes.
And when I looked on the web page, there was a multi-terrain vehicle design, 3D printed.
Yep. And they've provided all the software for it.
Yeah, it'd be good for the outdoor robot. Yeah.
It's a very, very interesting project. I'm surprised I haven't heard of it before. It's been around 3 or 4 years.
Yeah. Can I show that?
Sure, go ahead.
Sure.
Okay. Let me figure this out. Present.
I like the Donkey Kong version, because that's a really easy. I probably have 2 or 3 of those sitting idle on my shelf already. I just should throw my phone on one of them.
Yeah, so this is, I think I'm showing, this is the page. And so when I open up this, it's looks like you do a pretty good job getting around the rough terrain of for the outdoor robot.
Now their aim was $50 to produce the chassis, but I think that one's worth a bit more than $50.
Yeah, but it's 3D printed.
Yep.
Yeah. So probably the motors are more powerful, but it's pretty good. It looks good.
Yeah, show a few of the other ones there.
Oh.
They produced 7 different designs for bodies, for chassis. So that's the high end of the design set, but it was an amazing set of stuff.
Yeah, I was looking at the outdoor robot, because it's always interesting. So,
yeah, because most of them were indoor class.
Yeah. So the other ones that they had was like, I guess the DIY, look at the light one, I guess. I haven't looked at it, but
and they said if you want to buy a radio controlled truck, they designed a chassis, or they designed a body to go on top of a standard 1/10 scale RC truck.
Oh, cool. Okay. Yeah, that was one of those other ones.
Yeah.
Yeah. So this one here,
the one that says truck, that's it.
Looks like a tank. Yeah.
Buy one of these 4 or 5 different RC truck brands that you can buy at Walmart and throw away the cover that comes with it and put this one on.
Yeah. So there's pretty cool designs on here. It's good.
They are. So that's the OpenBot project.
Yeah, it looked like the 4-wheel drive one was like a skid steer, not 4 independent wheels, right?
Correct. Yeah.
Yeah.
Now they built a 2-motor version and a 4-motor version, but they're all 4 wheels.
Mm-hmm. Yeah.
Oh, the outdoor robot had 6 wheels, but yeah.
Mm-hmm.
And then the Donkey Kong guy said, 2 wheels are better, so here's a 2-wheel version.
Yeah, that's one of those things I've always wanted to explore. I know Kareem, I think, got into it quite a bit because of what they used on,
Yep.
you know.
Well, these guys make the point that your standard, 8-year-old Android phone has not only a camera on it and a huge processor, but it's got a GPS and it's got an IMU and it's got a temperature sensor and God knows what else it's got in there.
Yeah, and a camera sophisticated enough to work in, outdoor lighting conditions without, trying to compensate for, a kind of a narrow range of sensitivity and stuff. So
Yeah, I was tempted to use one of those 8-year-old phones in a greenhouse that I had 8 years ago.
Wouldn't that have been a brand new phone?
What?
If you use an 8-year-old phone in an 8-year-old greenhouse, wouldn't that have been 8 years ago? Wouldn't that have been a brand new phone?
Yes. But I thought about it. I used the Pi 3 instead.
Well, thanks, Tom. Any more questions for Tom?
Mm-mm.
Okay, Ted, are you still
All right.
on the line?
Yep. So let's see. My journey in robotics started with the SparkFun Autonomous Vehicle Competition. And for that, that's an outdoor contest where you drive around a parking lot, or your robot does. And for that, I found that at the time, like 15 years ago, GPS wasn't accurate enough. So we ended up using odometry and gyros. So, and that when you're just running a minute or two course, the gyros don't drift enough and to cause a problem, and you can get around within a few feet of where you intended to be. Now that I'm doing some other outdoor stuff that's not on a parking lot, I thought it would be nice to look at GPSs again. And I decided I wasn't really ready for the hassle and headache and cost of RTK. So I looked at GNSS receivers and found the SparkFun. I ended up with the SparkFun Max M10s. And that is a good GPS receiver, although a lot more expensive than some of the stuff you can get off of AliExpress or wherever. But anyways, I have a couple of outdoor robots, so I got 2, and that kind of led me down this path, and I will present here about, what could you do as far as taking, if I put both of those on a robot and average the, there we go, window. Yeah, we'll do this window. If I average the readings, and
readings.
So what I'm showing here is I've got the antennas mounted about 2 inches apart. And what I'm showing is the latitude. I used the UBX interface, and that gave me degrees. Well, it was 10 millionths of a degree in a 32-bit integer. So in order to work with it a little easier, I just subtracted an arbitrary reference point, and that's why the numbers go from 0 to 16. And those are feet in this case. I converted it to feet. And surprisingly enough, so there's like something like 32 satellites that they picked up at some point, but these 2 antennas right next to each other didn't really drift around together. That's what I expected to see, because they're using the same satellites. I expected the readings to kind of drift together, and they do a little bit here, but there is some separations where one will go north and the other one south. So you get some interesting stuff. Anyways, I guess what I just wanted to say was that it looks like you could get a little bit better results by averaging them together. And you know, this was over a period of 5 minutes. So the horizontal here is seconds and the vertical is feet. So, and it was 1 second apart was when I was taking the reading. So I took it over 5 minutes, just outside my house. So it was outside, but next to the house. So it may have gotten some interference from the house. But yeah, I just thought it was kind of interesting. I expected them to drift more together and they weren't. So I think you could average two, but I don't, just from what I'm seeing is it doesn't really look like it'd be worthwhile to do that.
Ted, that's really interesting. Now your receivers were mounted essentially next to each other.
Yeah, about 2 inches apart.
And they're the same models, right?
Correct.
Holy mackerel. I just bought an M10, a U-Blox M10 based GPS. I bought it from Alley, but it's got an extremely good reputation. And I was going to buy a second one because I thought they would track and I would use them for differential GPS. Maybe that will not work.
Yeah, from what I'm seeing, I thought about that also, Tom, but what I'm seeing is that is not going to work.
No.
Let's see if I can present.
I don't know if mathematically that would work anyway, right? If you have two things that have well, okay, the assumption is that their drift would correlate, but obviously it doesn't. So
that's the scary part.
Yeah.
I was thinking of doing the same thing, trying to calculate a heading even when the robot is stopped by looking at the difference between the two GPSs, let's say mounted a foot apart.
Yeah. Yeah.
I was going to show you. I lost track of which one I showed you the first time. But oh yeah, this is the longitude. And you know, it's similar thing, you know, at the start it kind of looks like it might be tracking together, but then in the middle they go wildly apart and kind of come back together at the end. So
I've been doing some research into the differential GPS idea a little bit, since it's not a new idea. It's a very old one and well established, 20 years ago before RTK.
Right.
And they said the thing you had to be very careful about, besides ensuring you had similar sky views, was that the two receivers you were comparing were seeing the exact same satellite constellations in use at the same time. And that may be
so
want to study a little further.
That's my guess here, is that, when it's got 30 some satellites to choose from, they're dropping and picking up different satellites at different times.
So I don't know whether you can force them to use a given set of satellites or not. The UBX command set has a lot of capability. So it may provide you with the option of saying, I want you to just use these satellites today.
Right.
And for this hour, because of course the satellite constellation availability will change hour by hour.
That seems like a lot of programming work to me, Tom.
Well, Bruce, maybe Bruce will volunteer to solve that problem.
There we go.
He'll sick Ader on it.
That's very interesting, Ted.
Yeah,
It really is.
so that was a fun project.
Thank you, Ted.
Yep.
Just for reference sake, my U-Blox U10 based unit the brand is Walk Snail. I've tested it a bit and I'm really impressed with it. So, and it was cheap, really cheap.
Yeah, maybe I should have just gone for that. I paid, I think it was $42 each for mine.
Okay, I paid, including shipping, I paid $20 Canadian for mine, including shipping. And it really works well.
I bought one the same thing. I followed Tom's link and I bought one for $20.
Yeah. They're really
$20 Canadian, so that's like, I don't know, $8 American.
Yeah, something.
Not that bad, is it? Oh my God.
It's getting worse.
It will, don't worry. Okay, that was good. Up next we had Scott, but I don't know if Scott's on the line.
Don't see. Oh, 3 others. I don't know.
So maybe we'll jump ahead to Mike. And if Scott joins, we'll go back.
Okay, well, mine's just a little show and tell. Basically, this artist saw my robots, and of course he said, "Oh, I need something for my art exhibit," and so he wants to rotate a painting on the wall. So it sounds simple. So what I'm doing is I'm making gears, and I decided to do the worm gear, where the worm gears to make it rotate. And so I have this motor here. Oops, there it is, and it's geared down to a 30 RPM, and so that's about a rotation every 2 seconds or so. And he's probably wants to rotate it at he didn't say, but once a minute or something. So the gears here will gear it down a little bit, and also just slowing the motor down should do it. And I got a motor, one of these. I pull this motor apart here. I was trying to I'm making it something for it to a cage for it, so I can mount it onto this system here. But this motor here has an encoder on it, so I'll be able to control the rotation rate and supply the power needed to the motor to turn it at a certain rotation rate. So that's sort of the project I'm doing.
Mike, how big is the painting?
Well, the first one he says is about 18 inches, but he wants to do larger too. So we'll see how this small one goes. But this worm gear, I'm trying to 3D print it, and these are pretty hard to 3D print, because I was noticing that you can't really 3D print something with a higher angle than 45. And so I was really constrained on what kind of gear meshing I could do. So I did. So I have this, and I have this motor here. This one here, and this one's printed nicely because it was more vertical. But this worm gear here was pretty hard to print because those gears were about 45, or I think those were a little more than 45, and a little less than 45, I mean. And they worked, but they were a little sloppy, so I filed them down.
Time to switch to a CNC machine.
Yeah. And so I'm putting bearings in it. So I have this bearing insert here that goes into this, and it'll go into here. So I have a good bearing mount between the motor assembly that attaches to the wall, and then the picture frame that mounts onto this big wheel. So I figured I needed a good bearing just to make it stable and reduce the frictions and stuff.
So your client is comfortable with having a fairly large gap between the picture and the wall?
Yeah, I was telling him 1.5 inches.
Okay.
About 30 millimeters, or maybe a little more, but and so it's basically says, oh well, that's fine. But some of my art has like 2-inch frames. So it's not going to be like a right next to the wall.
Mike, here you go. $15 at Surplus Center. It's a worm and worm gear unit. It even has the grease on the nut's gotten hard. Anyway, has a nut that rides on the lead screw, but you probably wouldn't be using that part of it. And on the back side, it's got a basically an insert for a 1/8 key that you can stick an encoder on. So, and it's fairly strong. I think you could support quite a bit of weight on it, on the shaft. But anyway,
you
won't have to make your own gears. So
you'll have to dig a hole in the wall, though.
Maybe, or you could cut the shaft off.
The painting.
I was wanting to make this a little thinner, but it just didn't scale properly. This is about what I could make with, because if I made the gears smaller, then they just didn't look like they're going to work. So so basically, it just keeps it like an inch or so from the wall. So that was pretty critical to keep it shallow.
Oh, keep it that shallow, huh?
Has he asked you to be able to change the speed of rotation?
I'll give him a potentiometer. Yeah.
So he does want that, eh?
Well, I assume he does.
you can buy very high gear ratio pancake motors that are designed to turn at things like 1 revolution per minute. And that might be a really simple solution. And they're pancake shaped, so they're thin and they're geared down already to very low speeds. And they're usually a squirrel cage semi-synchronous motor.
Like a clock, maybe?
Yeah. Well, a little more power, but you get them in a lot of places. We have Princess Auto up here, and Princess Auto sells stuff like that all the time.
Yeah, that might be a solution when he puts a bigger frame, and this just doesn't work right. Might have a little bit more power, so it'll be battery back because you don't want a cord hanging down from your art. So, so a little battery in the back and a little USB power pack.
We're back to the battery powered clock that hangs on the wall.
Yeah, rechargeable though. Yeah. Guess you could put solar cells on the painting and it could keep it charged and running all the time.
You could even use it as a clock if it rotates at the right speed, right? You know, slow enough.
Tell him he needs 2 pictures coaxially mounted.
So that's the project I'm doing. It's distracting me from my robotics.
That's interesting, Mike. Any questions for Mike?
Thank you.
Okay. Taylor, are you still on the line?
I am. I hope I'm not. Well, basically, I just have an idea to present. I'm just putting it out in the world, trying to get some feedback, and whether it's actually doable or worth doing. Admittedly, I'm new to the robotics, very, very new. I've done some programming and stuff like that, but essentially my idea is to create a robot that does metal detecting. I can't really find another product on the market right now. As I was kind of digging into it, I was surprised that there wasn't one that was at least available on the market. And basically, the basic idea would be, some sort of tracker outdoor chassis, and basically just a swinging arm for a coil that sends the signal back to the controller, can tell the quality of the signal, and that kind of was the general idea. There's a pretty big hobby market for metal detecting. And I thought, well, I like to metal detect. So it's like, it'd be cool if everything was just marked, the idea was just to drop a marker, when it had a good signal and just let it do its thing, and you could just come over and swing it. And, it'd be, cut down the amount of time, you could get more digging done. But as I was kind of thinking about it, I mean, there's really not that many things, like I said, on the market, but some other applications, potential applications would be for, industrial, pipe locating, underground infrastructure, kind of stuff like that. And then as I dug into it more, from a defense standpoint, there's really no robot that I can tell that does like mine detection. To me, it just seems like obvious, but I swear I just couldn't, and Google's funny. You guys could probably type it right in and find it, but I was having trouble finding it. But people literally go out in these minefields and with metal detectors walking these incredibly dangerous locations. But it just seems like a robot could do it so much better and safer. And even if it got blew up, it saved a life. It's like, anyway, that's kind of my idea. I just kind of wanted to put it out there, but really it's beyond my capabilities, realistically. But from a business standpoint, I'd love to do it. But or even just to see it work would be amazing. But basically, I'm just putting it out there. If anybody would be interested in talking with me, giving feedback, upsize, downsize, feasibility, anything, and I'm also willing to pay for time, consulting, whatever. So I don't know if there's any hired guns out here, but I'd be more than happy to talk to you. But
so available for free. So I think my robot, once I get, now that I've got past the Python package issue, I think my robot would do it. I think others' robots would do it here. So please jot down my name, connect to me so you can direct message me.
Okay. Well, actually, I was just going to, if anybody interested, I was just going to put my email here in the chat. Like I said, it's really early. Again, I was just surprised I couldn't find anything. But I'll take down your name, Bruce, and I appreciate it.
You could start looking at lawnmower robots. It sounds a lot like a lawnmower robot with a metal detector instead of
That's right.
plates.
That's right. Yeah. I was looking at track systems just because obviously it's, you could, a lot of places you metal detect are really pretty flat. But obviously the system would have to have some sort of object detection. And it was amazing. Sorry, I can't remember who was talking. Oh, Tom was talking about the camera and the object recognition for cameras that cost $60 or less. It's just amazing what's out there off the shelf. So in my mind, it seems easy, but having not done much of this, it grew out of my capabilities pretty fast. But
I can see it.
Yeah, but
I can see this robot having a spray can, spray paint on it.
Oh, that'd be perfect.
Oh my!
Yeah.
I've already
When it finds something, it'll
robot.
squirt it on the ground. Huh?
Yeah,
Okay, so-
X marks the spot. Yeah, I was thinking like, little discs or markers, glow in the dark markers, but ultimately, for higher end models would be GPS, marking, locating, see the map. I think there's a lot of potential for add-ons and stuff, especially in the defense and commercial. I mean, even to the fact that you can buy X-ray radar, ground detection systems that, I'm talking hundreds and hundreds of thousands of dollars probably, but it's, I've just been, as I've been doing research, I'm surprised how cheap everything is, for LiDAR even. It's like you can get a LiDAR system for a personal robot that's not that expensive. So I guess that's all I want to do is put it out there. And if anybody's interested or, like I said, have any feedback, I'd love to hear it.
Yeah, so my robot, I specifically call it a lawn bot, not a mow bot.
Mhm.
Okay, because my robot, I actually never intended on it mowing. That's just something I'm going to use it for. But a lot of places in the country, they use lawn irrigation systems. And so something I wanted to do was to be able to sense whether, to find the dry spots in the lawn to water them. Okay, and to do nutrition evaluation to see what parts of the yard needed what type of nutrient. So my robot is meant to be generic and to cover many types of terrain, have various different sensors on it.
Mm-hmm.
So hopefully now that I got past the Python package issue, I can go much faster. And the LiDAR, I use an more expensive LiDAR, the RP LiDAR A2, but I use Docker images. It turns out that there is a Docker Humble images for that LiDAR. And I had that working on my system weeks ago. So I have to get my motors working.
Oh, that's cool.
I'm also switching to the NVIDIA card.
Yeah, I've been watching some headlines or some information about the robots that go out into agricultural fields and zap the weeds. So that's pretty similar.
Yeah.
Right.
So something I haven't told you. Well, I think I started to tell you, but I was interviewing for a job for I said a very big lawn bot. It was actually a combine. Okay, and so I literally turned down the second interview because they just didn't pay enough. So they were only paying, I'm a senior guy, and they were only paying entry-level wages. And so I told them no. And my recruiter said, but they want to hire you. I said, I'm not working for that salary. And I'm retired, and I don't, I retired early, but I am retired, and I'm not going to come out of retirement for a job that pays what students make coming fresh out of college. But it does that. It checks for the nutrient levels, and they do all kinds of stuff. So
anyway, in Hawaii, that was the most expensive thing that I found. It's 3 rings that they're kind of like interwoven somehow, and they're 3 different types of gold, and it has it looks like Japanese, or I'm assuming Japanese characters inscribed on the inside of it. So it may have belonged to someone. I don't know. Well, I'm assuming it belonged to someone, but
yeah,
I don't know who it was. But
it's a good feeling
what?
to find something like that.
But so yeah, swinging a detector over lots of square area of beach, only to find a bunch of pull tabs and things like that. If you could have it do it. I thought about that when I was out there swinging the detector around and said, boy, it would be nice if something could just mark the spots, and I'd more than be happy just to dig up the spots that it found for me.
Right. I saw that Raj sent the exact robot for defense, the idea. I'm just glad it exists. My gosh, it just seems like really obvious. I couldn't find that one.
This is a pretty old project. I didn't work on it personally. I didn't have the clearance to work on it. But yeah, my colleagues worked on it. It was a pretty old project. I was working for Carnegie Robotics 2015, 2016. That's when they had this project, several $1 million project that they developed and made like 500 plus robots and delivered to defense.
It's I saw where like 5,000 people die a year, from mines, from wars forever ago. So yeah, I'm glad to see something out there. There's probably a hobby model somewhere that I just can't find.
Yeah,
I
that's
think
what I was
it'd be
thinking. I
decent-
didn't hear you completely. I just I was doing something and I just came back and I was like, hey, this sounds like something that that I've seen before.
Yeah,
So
no,
I picked
that's
it up from
amazing.
between.
It
Yeah.
even marks the
Uh,
edits.
Yeah, it's that. So that's a couple of, I don't know exactly how much they were selling it for. It was not really a lot of public information that, but the overall order size and things like that was pretty evident. That's how I think that was the first project for Carnegie Robotics. That's how they started the shop, and yeah, I was working on a different project there. But this project was like all behind doors and it's very secretive, and
Oh no,
once in a while
yeah.
we would see demos. But yeah. I'm
I'd
pretty
love
sure that there's someone who's doing it for cheaper, but based on the stakes and all that, I think Defense was ready to sponsor this project and do the research, development, ground penetrating radars, and all the custom parts. A lot of it was designed in Carnegie Robotics in house. The Carnegie Robotics is in Pittsburgh. The Pittsburgh company spun out of CMU. A lot of professors have stake in that company. So if you have any questions, I'd be happy to connect you to some of my friends
I'd
who work
love it.
there.
Yeah, definitely. I mean, what I have in mind is way more simple than this, but I mean, I think it would work for, keeping me from swinging 2 miles. So yeah. But that's pretty much it. Like I said, any feedback, feel free to email me, whatever. But thank y'all for letting me talk.
Yeah, I don't know if you guys have ever seen the it's like a huge flail. It's got like these weights on chains, and they,
Oh yeah,
chains are
yeah.
attached to a rod, and they spin the whole thing horizontally, and it just beats the heck out of the ground and
Right.
hits any mines that it can and explodes them. That's
Yeah.
kind of the brute force method, though.
Right. This is surgical. All right. Well, thank y'all.
Well, thanks, Taylor. That's an interesting application, and I hope you get some feedback and assistance in the help you go in the direction you're looking for.
Yeah, probably the most expensive thing I found was my next door neighbor's wedding ring. He
They didn't let you keep it.
No, he didn't. He wanted it back. So dropped it in the grass. So, and it wasn't anywhere near where he thought it was. So it's like I scanned pretty much his whole lawn.
Right.
Trying to find it. But eventually did.
Okay, well, I've got something I've been working on. I don't know if you guys can see this guy. It's got an OpenMV 4 camera on the front, a couple of yellow TT motors, a caster, a couple wheels. It's got a NeoPixel bar graph if I can ever get it going, but I'm having trouble with the firmware on the camera. It's not updated enough. It's quite an old OpenMV 4 camera. The idea with this is going to be line following. So put them back here, share my screen with you guys. Can you guys see that?
Yep.
So for some reason it thought it was an infinity mirror. So basically, there's the camera, the robot, looking at a track test sample I made.
Yep. Well, it looks like it's doing all right.
So basically, writing's a little fuzzy there, but I am working on trying to get the angle set up right and the math working. So right there, it's telling me I'm half a degree out. And if I stop if I stop, it's telling me I'm running at 15.5 frames a second with the video playing through the USB. I've got a measured angle of 88.8 degrees, and I've got a steer angle of 0.5 degrees. Basically, it's going through, I've got 5 different regions defined in the program, and it assigns a different weight to each region. I plagiarized a big part of this code from somebody else and just fine-tuned it for my purposes. And basically use that to try to just steer the differential robot to follow the line. The idea being that I can go through gaps in the line, intersections, things like that, without having too many problems. I've yet to test it. So unfortunately, the most expensive part of this robot is getting a line following course to follow. So,
oh, you mean a piece of vinyl with
a piece of, yeah. So the floor tiles or whatever, the floor tiles here, I can buy them for about $2 a piece.
Wow.
That gets expensive to build a track. So I think my next attempt is going to be on paper. So just using a painted line on a paper and see if I could follow that for now.
Just tape it to the floor is what you're going to do.
Yeah, I'll just tape it to the floor, paint it, tape it to the floor, and give it a try, see how it goes. So I'm going to start with a simple oval, follow the oval, and work my way up to some of the more exotic stuff to see how it'll work out.
Years ago, I did the line following, and I bought a stack of tiles, you know, and that's what I did.
Well, they used to be everywhere. You used to be able to buy those tiles everywhere for like 49 cents a piece or whatever. And
yeah,
now they're used in for commercial purposes only. Everybody can get them. They all got to be ordered in. You got to order them by the case, and they're $2 a tile.
That's crazy.
Yep. So that's what I've been up to. This is just a little side project trying to get the line bot going. The next one is going to be CanBot. So it's got to go for the Roborama in the spring. I've got an invitation out to Tom. Come north, have some fun at Roborama North, and see if we can put a competition together. I'm also open to travel. If I go south, I'll go south. Depends. If we can get more interest from people outside of our area, well, then we'll find a central spot and we'll join up and broadcast from wherever.
Yes, I think it should be possible to have something running. You were talking about line following. Let's see if I can hold this in front. You may remember this line following technology, a bunch of LEDs and optical receivers.
That's what I used.
Right?
Yeah.
This is out of a toy that used to be a line following toy where your kids would mark the line with chalk on the driveway, and this robot could follow the chalk.
So that chalk they use in lumber mills, usually it's a fluorescent chalk. It'll reflect an infrared light, and they use it for grading lumber, where you mark on the lumber by hand, and the camera snaps a picture, reads the grade mark and the trim pattern, and cuts the lumber and grades it.
Oh yeah.
So that's my background with that sort of stuff. So that was it for me. I'm frantically trying. 109 days, 108 days left. I've got to get my robot going and see if I can get some sort of cone detection algorithm going. I don't know if I'm going to use a camera or LiDAR. So I'm leaning towards LiDAR, and I'm trying to do it without ROS. So that's going to be my issue. I've got a couple different algorithms, finding where I am in the room finding corners, finding semicircles with the LiDAR.
You mean for this contest?
Yes. So I'm trying to put everything together and get something going with that. So that's going to be my next big challenge. So we'll start off inside of a box, get a big square box, a big rectangular box, 2 feet by or 3 feet or something, and put the robot in the bottom and see what we have for a pattern and start working our way up to a 7x10 arena. So that was it for me. Guess we can just, if anybody's got any questions, just do open mic and see where we go.
Well, I got something I could probably share. It's getting kind of late, but I don't know if y'all know I'm making that claw machine with a turntable. With this turntable, I was having trouble with the motors. So I had those worm gear motors on there, and the problem is, where are we at here? Well, I don't have to show. Well, yeah, I'm going to use a joystick, to turn the table clockwise and counterclockwise, and then I'll have an arm up here to go in and out. So I'm going to use a joystick. Now the problem is that when you move the joystick quickly back and forth, it would make my belts jump on the gear motor. So I decided to put stepper motor in there, and that fixed it. Except the stepper motor, when it's at low, when the PWM is real low, it wants to jump, skip pulses. So that's irritating. It's just irritating to me. I don't like that noise. So I find the reason why I did that stepper motor is when I disengage it to go the other direction, I can disengage it, put it in neutral, and it'll just float a little bit. So I can use a little delay to float it before they go back the other direction. And so I don't get so much jerk back and forth. With those geared motors, you had a lot of problems doing that. So anyway, here's how my solution of basically stalling out the stepper motor from a starting position and ramping it up. The back and forth worked great because I made a little routine in the code to disengage the motor and then engage it for a couple of milliseconds and then disengage it, and it worked real good. I wanted to show y'all with my camera here how I fixed my problem with my stepper stalling out. Can you see that there?
Yep.
I put 2 stepper motors in tandem on one belt. See, I had another stepper motor laying around there. So now I don't have it turned on or nothing. So now both of those stepper motors are fixed my problem. So I've got 2 stepper motors. I had one, I got these stepper motors just laying around, those little NEMA 17s. And I could have put a bigger stepper motor on there, but for one thing, I had these laying around. So that saved me some bucks. And I put 2 of them on one belt, and my turntable's working really good now. So real happy. That's cool. All I got. So I can move on in my project here now.
So that thing can rotate 360? That looks like it's got a huge area.
I can turn it on. Let's see. Where am I at here? Yeah. And here's the deal is I'm jumping off the same outputs off the Arduino to run 2 motors just by,
Oh, paralleling them? Yeah.
Paralleling it. So that way I don't have to, it made the code a little simpler. I like simple code because I'm a simple guy. Let's see here. Let me boot this Arduino up. Yeah, the turntable ain't on there right now, but you can see it. You'll be able to see it turn. All right, let's see here. You see it?
Yep.
Oh, something. Oh, push the wrong button. So I'm gonna have a joystick do that. See that? Go both directions, and the turntable will go any direction all the way around. But see, the claw itself won't go anywhere. It'll just go in and out. It's up there.
Yeah.
It'll just go in and out. And so the person would be able to line up, go back and forth and line up whatever little article they want. So it's going to work. I've tried different iterations of that. This seems like it's going to work.
Yeah. Oh, I thought the whole thing swung around, but
Well, now I was going to do that. Let me tell you, as a matter of fact, that's how I started out. Was the arm was going to swing, but the reason why I didn't, you got to think. I'm making this claw machine for our church carnival, which I've done another one in the past.
Right.
And you got little kids and I designed this to where they win. It's not designed. It's a design where they actually, and they play till they win. So if you got that arm swinging around backwards, the in and out, they're going to start getting confused on the in and out on the claw, right? So I just dumped that idea because it would just be too confusing for a little kid to try to keep up with what direction. So I said, well, let me, hey, I know what I'll do. I'll just put it on a turntable and leave the arm stationary. So that's what I did. The gantry up there, I left it stationary. So that's why it doesn't turn. Because you could picture how to get complicated. You turn around the other direction. The end would be out. It'd be all goofy. So
yeah, I was going to say you got some really nice looking guitars up there. I don't think you'd want that thing swinging around.
They're all cheap. Trust me, they're real cheap guitars. They're not that nuts. That's why I got so many. Instead of buying one $5,000 guitar, I buy several $100 guitars. So anyway, that's all I got.
That's cool.
Well, thanks, Michael.
Yeah.
Anyone else?
Well, I'm going to show you something. I have a treasure. I don't know. I try to search it. I can't find answer offhand. So I'll show you this thing and see what you all think of it. If I can click on, oh, grief, where is it? Windows, my map for, if I can find Ringo. Well, okay, we'll try it this way. I'll go there, share, and so is that working? Are you all seeing this window that says ISOBOT?
Yep.
Good. Yeah. Well, I find attachments for it, but I can't find the base robot. So I don't know if it's a robot they have on their site somewhere, or is it a kit that somebody has out there, or what precisely? Because I was thinking this one especially would be nice for like on the tabletop, or that.
Sumo looks like.
Or Sumo, yeah, but and they have attachments for it. But yeah, the base, the base robot is what I'm after. Because I don't know if y'all know where an ISOBOT is. If y'all find it, holler. I tried to do a Google search even. I got a walking robot, but not this. But if you look at it, it's sort of interesting because it looks like it's 3D printed bricks that they have on the side there that, like in this case, this attachment plugs into the wall there. So In other words, I like the design of it, and it looks neat. So, so yeah, if you have anybody have more detail at the base of it, I would like to know where it is. Otherwise, I may run out having to build it myself. But, or yeah, simplify it maybe.
And I'm assuming you already did a search on Thingiverse for.
Oh yeah, I mean, yeah. As I said, this guy seemed to build parts galore for it. You know, he has a gripper, dial version, a whatever this. I don't know what this attachment's for, but there's some other attachment for a MIRC, whatever that is.
Yeah. So, and he had no links on that first.
No, you go to any of them, and basically, yeah, all you see is just it. I mean, when I go ahead and click on this one, yeah, you know, just a summary, simple gripper, and then, you know, the license thing. But yeah, I mean, this one actually shows, sort of almost looks. That's why I say almost looks like it could be home built. But yeah, I like the idea of these rocks where you could snap in, sort of like thing. It looks like.
Did he have a link associated with his name?
When I went clicking there, you get like 2 of the images, but there's nothing that, yeah.
Yeah.
You know, I mean, the closest thing might be is this base, but they don't. Nowhere do I see these bricks on it, so that's why it makes me thinking.
I dropped a link in the chat that may shed some more light on it. You can have a look at that one.
Okay. So there might be a spot out there. Okay, I'll take a look at it. That was my impression. Though, and as I said, I like the design, and he has one. If we're doing the little Strumo thing, he even has one of these out there. Plus, so yeah, I'll click on that because I thought that was sort of interesting. You know, it looks like, it's modifying a kit in that case.
Tom, I'm not seeing your link in the chat.
Yeah, me neither.
Oops.
Okay.
Try it now.
Okay.
There it
is. Shop sharing. Go take a look. Well, yeah.
Made by Elvira Systems. Looks like it's probably European.
So that's probably why I
trying to
can't
run with a microbit.
Okay, so that's probably why I can't find it.
And appears to be quite new as well.
Cool. As I said, I like the fact that it looks like it has a snap-on system that you could add parts or subtract parts, and you had your basic board, and it's like a nice basic platform. So thanks for that.
Well, thanks, John. Anyone else have something to share?
I guess Scott dropped off, huh?
Yep, Scott dropped off. I didn't see him come back.
Yep.
Okay, guys. Well, thank you very much. A lot of good stuff tonight. A lot of presenters. It was a great meeting.
Thanks, Pat, for hosting.
Yes.
Yep.